Hello, and welcome to the U.S. Center. This is our NASA Hyperwall talk about climate impacts on biodiversity from our scientist, Laura Rogers. Let's give her a welcoming round of applause.
All right, good afternoon, and welcome to close to the last day of COP. So thank you for being here. I really appreciate you coming out. And today I'm really going to focus on climate impacts and biodiversity. So if you saw an agenda, at one point it said agriculture. We're switching over to climate impacts and biodiversity, but if you want to talk agriculture, I'd be happy to do that afterwards. But yesterday, a joint statement was released which doubled down on the focus of the biodiversity crisis and land degradation issues, and also specifically called out the need. I don't know if everybody can control that, but if we can stop the extra in the background. I'll just keep going. But yeah, it adds some flair, right? But we want to make sure that we're doing some of our conservation efforts equitably, right? So taking into account the indigenous people's knowledge and making sure that we understand all that they understand, because they have a lot to offer. So I'm going to go through this today with starting with the role of satellites and integrated observations, then go into a story, so really come from the storytelling angle of the Tikare program in the Gombe Desert, and which this effort was spearheaded by Dr. Jane Goodall. So I actually had the pleasure of being part of a Zoom interview with her a couple years ago. And she really talked about the importance of the satellites, imagery, the mapping, and being able to see the change to help in that understanding. She was so inspiring, as I'm sure you can all imagine. But one of the things that she said that really stuck with me was that everything is connected and everyone can play a part. And she truly believed that. And this story will help tell that. So, let's see. It also really resonated with me, as I often talk about Earth as a system, right? But we don't always directly include humans in that equation. So, we tend to talk about the human impacts more abstractly, but not necessarily lay them out here. So, case in point, this demonstrates the interconnectedness of the Earth and the fluidity of the oceans, the atmosphere, and even land cover. So these are all various observations we have, and some incorporate some modeling. But NASA has over 24 satellites in space monitoring and observing the Earth's vital signs, right? We're observing temperatures, clouds and aerosols, the atmosphere, ocean currents and ecosystems, vegetation, ice sheets. But again, less directly, we're observing human activity, and we're observing that through carbon and methane emissions, deforestation, and even groundwater pumping. But because everything is connected, we're also observing species extinction and the biodiversity loss. So this is an example of the type of data and information we can collect from space. This is a visualization is showing the deforestation of an area in, I believe, northern Brazil. And what we're seeing is it's going from forests to croplands and pastures over the past 3 decades. So that was initially just to give you a little bit of scale, but as you can see, we're starting in 1985. The green is forest, light green is savanna. But you can see the conversion to pasture and croplands as we move forward 30 years. And it's really striking the impact that this has, and I'll talk about the greenhouse gases in a moment. But we're also thinking about what that does for fires, and that, again, that connected impact to the emissions into the atmosphere, the smoke plumes, the particles, PM2.5, and so forth. This also not only can demonstrate the scale that we can look at things, but we can also demonstrate the ability to classify the different types of land cover. So again, we can see this from space, and it is really useful from a global perspective. But here we're going to go into what some of those compounding impacts are. So I mentioned some of the forests being converted. And carbon dioxide in the atmosphere is something we've talked a lot about here at COP. So it's a pretty mesmerizing slide, I know. So if you want to just stare at that, that's great. You can come in here all day and do that. But so carbon dioxide is the most prevalent greenhouse gas, and is really driving global climate change. Its increase in the atmosphere would be even more rapid without the land and ocean carbon sinks, which collectively absorb a lot of those emissions. So let's see where we are in this visualization. So I missed this first part. So this part is really, you can see on a 4-day cycle how the forests are really absorbing the CO2. That flashing is just that photosynthesis. Down here, that was a more constant ocean absorption. And what's interesting, if you notice, there's a pretty distinct line here. So where are all those carbon emissions? They're in the northern hemisphere. And again, that's because that's where the humans are. Those are the people that are doing this. And now we're looking, as we get into from the summer months towards the fall, we're starting to see it move more southern, right, into the southern hemisphere. And that's really because of the seasonality. As we move forward, we don't have as much of that carbon sink from the forests. I'll let that run for one more moment. All right, again, pretty mesmerizing, but then that's the 1 year accumulation. And really you can see some of those sources and sinks in this chart below. So we talked about deforestation and the Earth's ability to absorb some of that carbon and the amount of CO2 in the atmosphere driving up our temperatures. But how does this impact biodiversity? So every species has a niche environment that they really prefer. Kind of that Goldilocks statement, right? They don't want to be too cold, just like me. I don't like being cold. They don't want to be too hot. So they have where they like to be. Same thing with the vegetation. They want to, where's their food source coming from? What type of cover do they want to sleep? But as we can see from the time frame, this is a temperature anomaly. So in 1962, the average was here. It was a pretty small window, right? There wasn't a whole lot of range in temperature. But as we have been moving forward, you see that begin to shift. The average temperature is getting warmer, and we're also seeing a broader range of temperatures. So that's been difficult for some species. The other impact is, this is purely NDVI, so looking at the greenness, but you can take this over time and start looking at the NDVI anomalies. And we're seeing greenness starting to happen earlier in the months, so that changing that. But this really affects the migration patterns, right? A lot of species might have a long migration, but that timing over hundreds, thousands of years, they know the timing, they know when to be there, but it's changing rapidly, and not all species are able to adapt. And I really only said that because I just love this visualization, and I wanted to show this migration visualization. But this just shows the power of all the data that we're able to collect, and with modeling. So this is obviously done by modeling. These are not actually individual birds or whales, but we're able to see that interconnectedness of Earth again. It's just, I find this another just mesmerizing visualization, and how far and how often and how many, just incredible. But I said I was going to tell a story, right? So I'm going to get into the chimpanzees and the work done by Jane Goodall and the Jane Goodall Institute. So NASA's been working with the Jane Goodall Institute since about 2017 to address the rapid loss of chimpanzees. So chimpanzees are not migratory species, but they still rely on a stable habitat to sustain life. But Jane Goodall, in her wisdom, she realized so do humans, right? So as she was doing her early work, she saw that the human population was also rapidly rising. And she was seeing that impact on the environment. So forests were being cut down for timber, the land was being over-farmed and leading to soil erosion and numerous other problems. And that change in landscape also led to the rapid decline in the number of chimpanzees. But she also realized that unless we can improve the lives and livelihoods of people, we're not going to be able to address some of the other impacts specifically to chimpanzees. And so that's where this story really kind of begins. NASA and Jane Goodall Institute began using satellite imagery to show the people the impacts and how their current practices were changing the landscape, and how they can help to start understanding that change. So this is just a visualization of the deforestation from 1972 to 1999. You can see just in 27 years, with a lot of loss of forests. This is purely just another visualization of the Gombe National Park, where a lot of chimpanzees reside. But just you can see the distinct line between where the protected areas are in those non-protected areas in that rapid deforestation. Again, just a different perspective on what we're looking at there. But again, I mentioned these niche areas, and chimpanzees, their historic range, where they historically have liked to live, where they had that right temperature, that Goldilocks situation, covered a pretty good chunk of Africa. And it was all connected. If we fast forward, their current range has been significantly reduced. What's also interesting is we have little isolated areas. This creates quite a few issues when you start talking about reproduction, mating, right? Now we have a smaller number of species to connect. And just to point out where Gombe National Park is, you just saw that? That's right in this area. And you can distinctly see the line of the protected versus non-protected of where those chimpanzees are. So this is where Jane Goodall and the Jane Goodall Institute has implemented the Takari approach. So recognizing some of this change, we began introducing satellite imagery and satellite information through this Takari approach. And with these satellite images, they told stories, right? Working with the villagers, they told stories and they could understand. And between these images, the data, the human stories, again, we go back to that interconnection, biodiversity, the forest, the people, the experience are all interconnected. And through this, we began to see the importance of conservation. And so this is the PI, Lillian Pintia. I was hoping he would be here today. It looks like you're from Jane Goodall. I was hoping he would be here to tell some of this story, but he unfortunately is out with COVID. But we've got a photographer, but you can come on up at any time. But motivated by this understanding, having them see their land and see the changes, it really focused them on starting to understand they have a voice, right? So they began a forest monitoring program and created a training program for other villagers. And they really looked at, bringing in technology, again, to understand their land. So with that, they began developing land use plans for sustainable development and empowered these local communities to have a voice and to make some decisions for themselves. And now fast forward, we're beginning to see the changes that are happening. So there's hope, right? Understanding the landscape, understanding your impacts, understanding that we're all connected, we can see change. So beginning 2005, this is going to run to 2014, you see the reforestation. And it's really made a difference on this community. Again, in Jane Goodall's words, that there's hope. We can inspire change with hope. And that's all I have. So if you have any questions, I'd welcome them. Thank you.
Any questions? Please raise your hand. I'll bring the mic right to you.
Easy crowd.
Hi, Vivian with S&P Global. So we do research, this is my colleague here too, a lot of nature and biodiversity research on terrestrial ecosystems and linking impacts to companies who own assets that are, agrarian or mines or et cetera. But we have trouble with marine ecosystems, so I was curious if you have advice or resources or just thoughts on measuring biodiversity in marine ecosystems versus terrestrial.
I have a great anecdote for you. Not even an anecdote. In January, we are launching a mission called PACE. That is, what does that stand for? Phytoplankton. Aerosols, clouds, and ecosystems. And this is really looking at the biogeochemical processes in coastal waters and the ocean. So that can really be a resource if we're looking at marine ecology. We do depending on what you're looking at, we have a lot of resources in that world as well. We've got some LiDARs that can look at some of the more specific. You can get into as long as turbidity is low, you can see into the initial column of the ocean, and you can see what type of phytoplanktons are living there as well. So we have a lot of resources, but really looking forward to PACE. that will be a great resource for you. We also, not too long ago, launched SWOT, the Surface Topography, Surface Water and Ocean Topography. I'm not good at acronyms, I'm sorry. Surface Water and Ocean Topography mission, and that is really going to change the landscape of our understanding of water on planet, whether it's rivers, coastal systems, oceans, but that is going to be a great resource as well. So if you have a specific question on what you're looking for in the marine ecosystems world, there's a lot of resources. We have projects looking at corals, we have projects looking at sargassum, harmful algal blooms, and so forth.
Hi, I'm also from the Jane Goodall Institute with Devin here, so thank you so much for showing that example. I guess my question is, we use data a lot in our community center conservation program, and the GIS, the mapping has been great. What is sort of like the next thing in terms of what NASA is doing? Is this just a high quality of the images, or are there other kind of more frontier things that you're working on?
Yeah, and that's a great question. So thank you for asking that. So when we think about satellite data, we think about it in different realms, right? So there's imagery, right? And we've got Landsat. Landsat Next is coming up, but we've actually done transitioned a lot of our imagery work to the commercial sector. They're doing very high resolution imagery work, and we're looking more into the various different types of observation. So we like to see we can see the unseen, right? So the data, the information that we can characterize from the observations as opposed to the imagery. So as far as new frontiers, we've got a couple things coming up. So we are launching NISAR mission soon, and that is a synthetic aperture radar. And from a marine ecosystem, that's going to be looking at deformation of the surface, and that has a lot of coastal impacts. But it's globally, any type of deformation or change in the Earth's surface is going to have a lot of application. So that is what's coming up in the very near term. But we've also, based on the last decadal survey, we've got our Earth System Observatory that is in formulation right now. And that we're going to be launching what's called a Surface Biology and Geology mission. But we are just looking at different types of hyperspectral instruments. So commercial's doing some of that, but we're going to be looking more global, looking at different types of constellations of satellites and how we can integrate those measurements. There's a lot on the frontier. We're really looking at different ways to do things, whether it's from shrinking them down to smaller, or more the using AI to really bring the imagery, bringing the information together along with the airborne and the in situ data so that we can have a better holistic understanding.
Hi, I'm Jeff Isaacson of USARA. Love the talk. You've got me thinking about what is driving deforestation. Can you say a few more words about human encroachment, industry, effects of the changing climate? It actually affects the policy prescriptions that we might discern from that. Thanks.
Sure. I mean, that's a tough question, right? There's a lot of hypothetical what's driving deforestation. Obviously, in this example, looking for timber and for urbanization and for building, for paper, right? Looking at how we can do that. There's a lot of illegal deforestation in some. Can you ask the second part of your question? So what's driving it? There could be all kinds of, what the business model is behind it. That's something that we can't see from space. We can't understand. And I think that's where we have some gaps, and that's where we want to work with our partner organizations and those indigenous communities that really understand it. We can't see that, right? But we can work with partners to understand, and the information and the seeing it from space and seeing the change may provide clues into what is driving that. So that is where the partnering and the relationships really matter, and where we're looking and who we're working with and what's driving the action. I don't know if I answered your question, but I'm happy to talk more.
Any more questions? If not, another round of applause.
Thank you.